Okay, so two more hypothesis tests. I'm going to do the first one, pause, you can do the now you try, and then I'll do the second one. Okay, so let's have a little work through this. There's a little difference on this to the other ones that we did before, but the same principles apply. I'm going to be following this framework, so I'm going to state the null hypothesis, I'm going to do the alternative hypothesis, significance level, describe the distribution, calculate the test statistic, which is the probability, compare the probability against the significance level, and then make my conclusion accordingly. Okay, so let's unpick this one. So really important to read the question carefully. So tulip bulbs are sold in packets of 56 mixed colours, in packets of 56 with mixed colours of red, yellow and white. So a little typo there, I think. Random samples of bulbs are obtained and put into packets. A packet is selected at random and the number of white tulips is found to be 10. So 10 out of the 56 are found to be white. Investigator to 5% significance level, the claim that 20% of bulbs sold in such packets result in white tulips. Okay, so let's start and work through this with the same steps as normal, and I'll discuss the differences as we go along. So I'm going to state my null hypothesis. So I'm investigating at 5% significance level the claim that 20% of the bulbs are white. So my null hypothesis is that the probability of picking a random bulb and it being a white tulip is 0.2. The alternative hypothesis, now what we're testing here is that it is 20% or it's not 20%. Remember the previous questions that we did talked about an increase or a decrease. Let me just remind you on that. So this question said the claim that less than 15%, and this one said the company claims that more than 40% arrived early. This one is just checking for change. It is checking that it is 0.2% or it is not 0.2%. So rather than that being a greater than or a less than, it is a not equal to. Okay, that's really important in this question. Right, so I'm going to state my significance level. So the significance level is 5%, and this is a two-tailed test. Okay, and the reason it's two-tailed is because if our test, whatever we test, turns out to be significantly higher than 0.2 or significantly lower than 0.2, then we may be able to reject H0. So we're testing both sides of it rather than just a greater than or a less than. So that's what the two-tailed means, and that's very important when we do the check at the end. Right, so let's carry on. So now I'm going to state my distribution, assuming H0 is true. No difference here to the previous ones we did. So we are checking our packet of 56 to see whether the probability is any different from 0.2. So that's my distribution, assuming H0 is true. I'm now going to calculate my test statistic. Now, to do that, I just need to check whether I need to do a less than or a greater than. So what I need to do before, and this is an extra step now, is to just calculate what we call the mean. Now, if I've got 56 bulbs, and there is a 20% chance of each one being a white tulip, then we would expect 56 times 0.2 to be white tulips. which comes out at 11.2. So that is what I call my mean. That is the expected value. Now, can we see that what our test has come out at 10? Okay, so we've randomly checked these 56, and 10 of them have turned out, which is on the low side. It's on the low side of what we expect. So what I need to do is to check what the probability of getting 10 or less. If, say, this number had been 14 on the high side of the mean, then I would have done a greater than or equal to. Yeah, so I'm checking. So I know this is on the low side, so I want to know how unusual it being that low or lower is. Okay. So I'm going to do my BCD on the binomial distribution based on this. So I've got a lower of 0 because I'm going less than or equal to 10. I've got an upper of 10. My number of trials is 56 and my probability is 0.2. So what is the probability of that happening? And I get 0.420. So it's not that unusual. There's a 40% chance of this happening. Right, so I compare that against my significance level. Now here's a key difference on this one. So what I need to do is to compare my test statistic against my significance level. But because it is two-tailed, I need to compare it against half of it. Okay, so I'm not comparing against 0.05, I'm comparing against 0.025. I think the result of this wouldn't have mattered because this is going to turn out to be greater than, isn't it? So this is not that unusual, and it is greater than the significance level that we are setting. So in this case, what I say is I accept H0. Okay, and then we need to make the statement to say what this really means. Okay, so this means there is insufficient evidence at a 5% significance level to suggest that there has been a change to 20% of bulbs being white. So I'm tying the statement back to the actual question and making sure that this statement relates to exactly what we were changing and the context of the question is referred to. Okay, so I want you to do the now you try. I want you to pause the video and I will do the example. So pause now. Okay, so hopefully you have completed the now you try. I'll do it now and you can check your answer versus mine. Okay, so let's understand the question. Prior to joining a coaching course, a netball player scores 45% of her shots. In games following the course, she scores with 72 out of 135 shots. Investigates a 5% significance level to determine if the coaching coach has changed her shooting ability. Now the key word here is changed. So what we are saying is it different from 45%? We're not saying has it increased it, we're saying has it changed. So I suppose it is a reasonable scenario to check that a course could reduce someone's shooting ability. It could adversely affect her ability. So that's what we're checking for. So let's quickly do that. So I've got 8-0. So the null hypothesis is that she scores with 45% of her shot. So the probability of a shot going in is 0.45. The alternative hypothesis is that it has changed. So it is a not equal to. And that there immediately triggers the fact that we are going to be doing a two-tail test. Okay, it's not a greater than, it's not a less than. Okay, so I'm going to state that here. This is very much about organising my thinking and making sure I don't make a mistake. So I'm going to, I've written significance of 5% and two-tailed. Okay, if 8-0 is true, I have a binomial distribution. She's taking 135 shots, and the probability of scoring a goal is 0.45. Excuse me. Right, so I just need to check. Now she's scored 72 out of her 135, so I just want to check whether that is on the high side or the low side. So am I going to do a greater than or a less than? So I'm going to calculate the mean. So the mean is n times p, that times that, which is 135 times 0.45. We stick that in a calculator. I've just done this before, so I'll just write the answer down. It's 60.75. Okay, so if the probability of scoring is 45% or 0.45, we would expect there to be about 60 out of every 135, whereas she's scored 172. So that is on the high side. So the probability of x being greater than or equal to 72 equals, so where are we now? So greater than or equal to 72. So this time I'm going to do 72 as the lower, upper is 135 because that's the most we can have. The number of trials is 135 and the probability is 0.45. Okay, so that is what I want to calculate using BCD on the binomial distribution. Calculate that and I get 0.0318. Okay, so I now need to compare my test statistic or my probability on the assumption that 8-0 is true against my significance level. Because it's two-tailed, I need to compare against half of my significance level. Okay, and we can see that that is greater than that, just. So what we say now, because it is greater than the significance level, we accept 8-0. Now that doesn't mean that 8-0 is true. It just means that there's not enough evidence in this test to suggest otherwise. So we accept 8-0 and then we get the words right. There is insufficient evidence at a 5% significance level to suggest that her shooting ability has changed. And that should be okay. All right, okay, oh, that was helpful.